Okay, so my talk is an introduction to Python. I like to use Python notebooks, Jupyter notebooks, to do the Python because it gives me a chance to be very interactive. So I can stop and I can show you how something works, that sort of thing. And I think I'll just take questions whenever you want because, quite honestly, you could read through this without me and probably get a good 90% of what I'm going to talk about. So it's okay if we don't get to the end. So okay, let's start. Well, what is Python? Well, it's a free open source language. It's sort of object oriented. It supports object oriented programming, which I'll talk about next hour. It's got really strong community support. There are thousands of packages that you can download from PyPy, which is the site where they store them. Some examples of the libraries that are the packages you can get. I think they call them modules. Are things like SciPy, NumPy, Pandas, MPI for Pi, which lets you do computational science sort of things. PyQt for GUI interface development. There's APIs for LinkedIn, Craigslist, Google, and Beautiful Soup. Of course, you can do machine learning. Anybody who was on the line earlier knows about that. You could also do natural language processing with NLTK. And you can actually do facial recognition using very few lines of Python with Py2FaceR. So there's a whole bunch of libraries that support some very sophisticated things. Objects can have properties and methods in Python. Properties are, of course, something that contains a value like the name or a location or something like that. And a method is something that the object can do or that Python can do. And all of this, Python basically allows you to automate very time-consuming complex processes so that you can work more efficiently. As I was saying, I think about 10 minutes back, Python's glue. So you get this huge library that supports machine learning from TensorFlow, and with just 100 lines or even less, 50 lines of Python, you could do a relatively interesting machine learning application. So let's talk about how you get it. Well, Python is free, but it's curated by several organizations, some of them for profit. So I think Anaconda and Enthought provide enterprise support. A lot of companies use it to indemnify themselves against any licensing issues, maybe handle their distribution issues. But by and large, what you get as an enterprise versus an individual is pretty much exactly the same thing when it comes down to the module level. And then, of course, you can get it directly from python.org, which is another good place to get it from. And I mentioned all those modules that are available. They all come from this organization right here, PyPy, which contains currently somewhere over 130,000 different packages. So there's, like I said, there's something in there for everybody. And if you're one of those people who don't want to make any commitments at all, you can actually run Python in the browser. If you go to Python Fiddle, and it will let you type in 50 lines of Python and execute it and see what happens. So it's a really great way to just get into the whole Python thing without having to install any software at all. So let's get some miscellaneous things about Python out of the way. It's not compiled, it's interpreted. It's case sensitive, so uppercase name, lowercase name would be different if you were referring to it. Python uses indentation to define code blocks. What this means is there aren't any squiggly braces, there's no begin and end on an if or any of that. It's just if and then indent. And it's very picky about it. Sometimes if you mix your tabs and space indents together, it will complain. But by and large, you'll get used to it pretty quickly. And it's not too terrible. Python uses the hashtag as the mechanism for commenting code. And if you want to comment multiple lines, you could use the triple the triple quote. So you triple quote, and then below it you would triple quote. The things between those two triple quotes would be commented out or not executed by Python, in other words. Star is a wildcard character in strings. So it's useful for identifying specific files, so you can do this sort of thing. And of course, a single equal sign means assignment, where the double equal means equality. So the data types, basically numbers. They could be integers, long integer, float. Strings, of course, contain text. Lists can be lists of ordered numbers, strings, and anything else. And it can be a combination of data types. There's no requirement that a structure contain a homogeneous set of data. So that could be very useful, and it could be somewhat perplexing depending on how you do it. Dictionaries are basically key value pairs of values. And of course, again, it doesn't have to be homogeneous at all. And tuples are a special kind of list in a way. It's a list that's immutable. And one of the reasons tuples exist is because dictionaries need to have a index that's constant or immutable. Because you can imagine if you could put an element into a dictionary for something that had an index that could change, then you can't find it. So that's one of the reasons why tuples exist, because they make dictionary indexing easier. So let's talk about numbers. So you assign numbers using an assignment sign. You could convert numbers between integer and float by using int and float. By and large, you'll just care that things are int and float. You won't worry about long or any of that. Numbers can be converted to strings by using the str function. And you can't concatenate numbers and strings, but you can concatenate strings with an equality sign. And so let's go through some examples. So right here, I can assign the number of the value 14. Oops. I can make it a floating number by just doing a float to cast it to float. I could cast it to an int, and I can make it a string, and now I see it's quoted. In this particular example, you're taking a number and you're going to print it. So I can say that S is going to be assigned a string whose value is number equals, and then this particular thing here says, whatever this first value is, put it in here. But I can also do it like this, and this is sort of an advanced topic, but you can see this is how you would print values, which is just useful. And here are all of the different operations that you could perform on a numeric value. So you can see you have modulus, exponent, floor division. You really have all the things that you need for math. If we go to strings, you could define a string using either single or double quotes, but if you start with a single quote, you have to end with a single quote, so they have to match. Strings are just a collection of characters. Actually, they're just an array of characters. So you can actually access them with an index. So here's an example of using a double quote versus single quote. And here's an example of indexing into that value for each of the individual characters. You can use backslashes as escape characters in Python. And if you don't want to do that, you can use the R and to tell it basically that the string is raw and that there aren't any escapes in it at all. So here is a string that is escaped. So the slash is escaped with a slash. So that's why there's two of them. But I can also just say, look, the string doesn't have any escape sequences in it at all. So it's just a raw string with the -R, or with the R there like that. So the first string and the second string basically come out essentially the same. And finally, here's an example of concatenation using the plus sign. So I can take two strings and I connect them together. And there are actually a ton of methods you could use on strings. These are only a few. So we can check to see that the string starts with a certain set of characters, ends with it. You can ask questions like, is the string all alphanumeric? Is it all lowercase, uppercase, that sort of thing? You could replace values in a string. One I use a lot is split and strip. So if you want to take a string and tokenize it, I can split a string basically by the spaces, which you can see an example of. This is actually split by slash. And of course, I can strip a string, which means that any white space either on the beginning or end can take off. Any questions so far? Because some of this this part gets a little dry. Okay. When you get to lists are an ordered set of data elements, and you use a set of square brackets to define the fact that you have a list. So this is an empty list, and this is a list of 3 strings. They, of course, can have different types. So I could put, this won't actually break anything. I could put the number 1 there, and when I execute it, we're still okay. In fact, I could just say print. It turns out that print doesn't care what type it is either. So I can literally go in here and say, oh yeah, whatever's in the 3rd position, just print it, it doesn't matter. It's dynamically typed. The whole language is dynamically typed, and that's why we get away with this. If we want to retrieve a specific item, as you can see, I used an index to get to the nth element in a list. And I can use something called a list comprehension to create lists sort of without having to have a while loop or a bunch of assignment statements. So here's one way to make a list. But what if I wanted to get a list of all of the even elements in that list? Well, I could make a while loop and say, is this divisible by 2? And if it is, put it in the other list, and continually do a for loop to do that. Or I can use this list comprehension, which basically is going to say, take this list, enumerate over it, take those enumerated values, call them X, and then put X in the list if and only if X is even, which is, in other words, the remainder of mod 2 is 0. So if we run this, we'll see 2 lists. We got the list we originally started with, and then the list of only even values. I believe 0 is not necessarily even or odd, but I'm not sure.
We have a question in the chat.
Sure.
Sorry to interrupt.
Oh, it's up here. Yes. Programmers here. So lists are arrays. Yeah, basically. But you don't have to pre-allocate them. You don't have to predefine how long they are. You can add things. You can delete things from the list. I think the word is .append, to append things to the list. But you don't have to say, I have a list of 100 things and then get into a situation where if I want 101, I got to make a new list. You don't have to do any of that. You just slap them in there. So here are some of the things. Okay, here are some of the things you can do with the list. You can append a list, append to it. So if I append E to the list, it will just stick it on the end of the list. I can append a list on a list, and this has got to be a little careful. So if you use the word append and you put, if E were a list, it would end up being a list inside of this as an element. So in other words, can we do that? Yeah, we could do that. Well, let's make that 1. So what we'll do is we'll say list dot append list 2. Now when we run this, it's a list of the original numbers, and then we stuck that list in here. And this is sort of use the word extend, I think it is. It actually just adds them as elements from the other list. So there's both list, append, and extend, and I don't mention that here, but it's useful to know. I can certainly sort the list. I could reverse the order of the list. So I can say, I don't know what I did. I broke something. Why? List reverse. You like that? Well, that makes me feel. Oh, I know why. I know why. I know why. He does it in place. There's no return value. There you go. That's why. You can remove an item in the nth item in a list, or remove an item by its value. You could certainly insert after some point. So inserting after 0, well, insert before, and it puts it here because lists are 0-based indexed. And I can get the count of the list. And of course, get the count of a string probably returns, I'm going to guess, the number of characters in the list. So it's like len. We also have something called dictionaries. Dictionaries are unordered sets. So if you iterate over a dictionary, you don't necessarily get them in the order that you created it. That's not guaranteed. And you create a dictionary with curly braces instead of square braces. The items in the dictionary can have different types, of course. So as you can see, here's a string, and here I'm putting in a 1 for the dictionary element cat and dog. You can index by things other than the numbers. To retrieve a specific item, you just reference it with the key, like here. And you can use something called dictionary comprehensions to do the same thing, form sub-dictionaries of the dictionaries you have. So let's just finish this first. So here I'm basically creating an empty dictionary, adding 2 elements, and then I'm asking to print the dictionary elements. There they are. Here we're doing a dictionary of city populations. We're going to get everything in the dictionary, which comes out like this. And then finally, we're going to just say, what's the population of Austin? Now, as I said, there's this thing called dictionary comprehensions. In this case, what happens is you're going to take this dictionary and say, I want a set of items from it. And those items will have key values, so KV. And you want to put the KV, the key value, into your new dictionary. And you want it to be there. We could do this. You want it to be there only if the populations are even. So we can see that Austin's odd, so it didn't get put in, and Dallas and Houston have even populations, so they're in. And when I meant items, if we just do this and hit enter, we can see what we get as far as items. And what you end up with is kind of a list of tuples of the values. So it's actually doing some sort of conversion temporarily so that you can see that you can do this comprehension. Dictionaries have a set of methods that work well with them. I can get all the items in the dictionary, which I said are a tuple of key value pairs. I could get a list of just keys. I can get a list of just the values. I could pop a key, which basically says, return me the value for that key, and then remove it from the dictionary at the same time. And of course, I can remove everything from the dictionary as well. So just want to stop and ask any questions. Let's do this. Okay. Just checking the time. Okay, so let's talk about tuples. Tuples they're kind of like lists. They really are. In fact, really the only difference, the biggest difference that comes out of them is that they're lists, but they're immutable. So you can't change them. And that's why we can use them as indexers into dictionaries. So here I'm making a tuple, and to make a tuple, I use the parentheses. And so this is going to be a tuple of 2 names. And I print the first one, person 0. Here, I'm going to create a dictionary, and I'm going to index it with this tuple, and index this entry with this tuple, and that entry with that tuple, and then I'm going to print the whole thing. So now you can see that a dictionary can be basically indexed with a collection of other values, as long as they're constant. And then, of course, when I do this, I get an error. Does anybody have an idea why that is? Okay, well, it's because as I said earlier, tuples are immutable. So once this tuple is formed right here, I can't change any values in it. So I can't put not Chuck right here. Now, on the other hand, if I do this, it works. And it works because now it's a list and it's mutable. Right? Okay, let's talk about conditions and loops and that sort of thing. So all conditionals and loop statements end with a colon, which signifies that's where the end of the Boolean or whatever statement, if statement is. And the code is nested using either tabs or spaces, but you have to be consistent. So let's look at something called the if and else if and the else. So as you can see, I set a value for pi, and then basically I just have an arrangement of if statements. So if pi is greater than 4, then pi is greater than or equal to 4. If it's greater than 3, well, else. If it's greater than 3, then it's greater than or equal to 3. Oh, equal to 3. Well, you can't do that. Greater than or equal to 3, but it is less than 4. And of course, the else here is that pi is not greater than or equal to 3. So if I run this, it should be the last one, right? Pi is not greater than or equal to 3. And so you can have as many cases of if by putting an else if in as you want. You can also nest them. So here in this example, I have an if statement and I print something. Otherwise, I have another else statement, in which case I have another if indented. So this occurs only if, and this is basically the same thing as an else if. The same as this one up here. Let's talk about a for loop. So for loops actually have an else part in Python. So you can say for, and then you can else. And the else is executed no matter how many elements are in the list. I think that's what I got done here. Hang on. Loops are used to iterate over a collection of elements. You can use break and continue just like you can in C to get out of a loop prematurely. Unlike other languages, it has an else clause, and I'm going to introduce this notion called range because you don't typically say for I equals 0, I less than something, I plus plus, like you do in C. Instead, you say for X in list, print. So this is basically a for each, and as you can see, it prints each element in the list. If I don't have a list of elements, but I want to iterate, like you would say in Fortran or C, where you would say for X equals 0, X less than 10, X plus plus. You do that by saying range, which temporarily builds an iterator. In Python 2x, it would actually create a list of the values and let you iterate over them. Now it actually builds an enumerable object so that it doesn't grow without bounds. If you say I have 10,000 items there. So if you run this, you basically get the same thing you got before, because this is creating an enumerator that will enumerate over the values 0 through 9 or 1 less than 10. It's exclusive of the last value. In this example, I'm going to iterate over the list, but in this case, I'm going to use the else to say there were no elements. So when I run it, it says there are no elements. Now I thought if there's one element, it still runs. So the else gets executed no matter what.
We have another question in the chat.
What are examples of where you would use a dictionary instead of a list? Okay, so first of all, to clarify the part about immutability, the immutability is only required for the key in the dictionary. So I can't think of too many cases where I would have this situation where I would change the key. You would never change the key value of a database, right? Of a database element. You would add a new element with a new key value, delete the old one. And that's the only thing you would have to do here. The advantages of using a list, a dictionary over a list would be if you naturally have things that are associated with a unique value. Like if you wanted to create a bunch of named records for your employees, you give them an employee number, and that would be the key, and the value would be an employee record, or an object contained all the values about the employee. So it's just like a mini database in memory in a sense, right? Did that do well? Okay. So let's go on to a while. Again, you have the else clause as well. I'll try not to go into that too much. But here we're iterating over some values. We're iterating as long as our value is true. So in this case, for instance, count is 0, and as long as count is less than 9, I want you to print a message and increment count by 1. And so we should get this to run basically 0 through 8 times. Yeah, 8 times. It's just like C. If you're used to, you might even see this in BASIC. I don't know. I don't know what your languages are. And again, it's funny. That Michael was talking about removing finally. It's basically a kind of like a finally. In that once this loop is done, it's going to print that value no matter what. Hey, it's never less than 9. Well, it doesn't matter. We could actually put anything there. And I guess we could test the count and put more logic down here. You might use that to close a file. So you might open a file here and you might say, wow, this is true. And else put a carriage return so that no matter what got printed, you have a carriage return at the end of it, and then close whatever file. In this example, what are we doing in this example? Count. We're counting. Oh, this is just going to say it just does it once because it does nothing. There's nothing in the loop to do, so it just does the else. And again, don't be put off by the fact that this says it was never less than 9. It's just always printed. And you can make the smallest loop possible, and this introduces a new statement called pass. Pass is really good if you're putting down you're laying out the logic foundation of your method, and you want to make a while loop, but you don't want to put anything in it yet, and you want to do the other stuff, and you still want it to not complain. You can use the pass, and pass means do nothing. So in a sense, this does nothing. It just basically loops forever. Oh, we shouldn't run that. Oh no, it doesn't. It doesn't loop forever because count is 10. We're okay. So it only loops once. If I make this count less 9 or less than 9, This would go into an infinite loop because count would never get incremented and it would just never break out of the while. Any questions? How am I doing for time? The next one is 3:30. Okay. Not bad. We'll have time for questions. So modules are kind of like the includes in C. You're pulling in some other code, someone else's work, some other features to help you with your application. At some point, you'll want to go to PyPy and you want to use some of those modules. And this is how you import, once you've installed them into the Python environment, this is how you would use them within a file of Python code that you have. There are several core modules that people use consistently quite a bit. OS and sys, because they're operating system and system specific kind of functionalities. There are methods in there to tell whether you're executing on Windows or Linux if you want, if you need that. You can do the Unix style pattern matching, and you can manipulate CSV files for reading and writing. But the simplest form, you say import sys to bring in system specific parameters and functions, one of which is version. And whenever you use something that's in sys, you have to say sys.version. So that's how I would refer to the version value in the sys module. Now, maybe sys is too long. Some of the module names can be longer than 3 characters. And so if you say import something really long and you want to make it short, you could say whatever, in this case, O. But if it was one of the things, for instance, pandas, people will import pandas and they'll say as P. Then they can just say P dot whatever. So you can rename the package in a sense that you want to refer to it as. And finally, you can bring into your namespace only 1 or 2 or however methods you want from a package. Now, let me explain what I mean by namespace. So the module has a namespace, which is qualified by the module name. That's why we got there. And you have a namespace, which is undecorated, so that you could just refer to things like, I wrote a method called foo. And so I can just refer to that method and I don't have to prefix it with anything because it's me. And so I can say from the time module, I want you to take sleep and I want you to put it in my namespace. So now it doesn't have to be qualified at all. And so I can just say sleep and it just works, no problem. And we slept for a second. So we use the sleep function out of time without any prefix at all. And if you're really brave and you want to just get everything from a package, you could go from package name import star, and basically everything will be put in your namespace. And it turns out there's a function in that package called rand_init, which gives me a random integer. And so I can just use that method directly as is. Now, what's really interesting is, and I'll talk about this in my next talk, there's no such thing as public and private in Python. So when you're doing things like object-oriented programming with classes and whatnot, everything's really visible. But they use underscore as sort of a hint character for certain behaviors. And one of those behaviors is that if the method has an underbar in the front of it, in the front of its name, this command will not import it. So you don't have to worry about polluting someone else's namespace with your developer variables that are internal to your package, if that makes sense. And I went really fast, and I'm open for all kinds of questions. And we can just talk if you want. And did I mention at the top, and I didn't mention it, in fact, at the top of this, and I put it in the chat when I was getting ready to give the talk, there is a link to the GitHub where I store all of the Trenton Computer Festival material that I have. So please feel free to go there, hold them down, use them if you want. I think if you look, in fact, here, this is it. If you go there, it tells you, a little bit about them, the two different packages. I recommend, some reading. I found a Python Easter egg, which I thought was kind of cool. It's about their design principles, basically. And I hosted the Jupyter notebooks on something called Binder. This is the object. On Binder, which basically means you can use the interactive notebook in your own browser from GitHub without having to install anything. Setting up.
We just got a question in the chat.
Yes. It is what you presented in version 2.6. Yes, what I presented is 3.0. So it's actually, I think I'm running 3.6 or 3.7 right now. The biggest change that I've seen that bothers me the most is the way it prints. But I got in really at the tail end of 2.7, so I didn't have a big investment in Python before 3. And do you have a favorite version of the language? I've heard a lot about Circuit Python. How is that different than Python? Ooh, I don't know.
Hello? I think, hello?
Yeah,
I think
go ahead.
I can help you with that. Circuit Python is a subset of C Python, which is what we're looking at. And it's designed to work on microcontrollers and small single board computers. That is the primary difference. First of all, it's a subset. It doesn't have everything that C Python has, and it's designed for small microcontrollers. For example, Raspberry Pi just brought out the Pico, the RP2040 board, and CircuitPython runs on that board. But
so it's smaller. It's a little thinner.
It's thinner and it's a lot smaller.
Now they're actually talking about taking out a lot of the built-in packages that have been there forever. A lot of them that no one uses, which will make Python a much smaller language to install. And then as you add the features you want, that's great.
CircuitPython does exactly that, because it allows, what we do is there are boards that you can attach to these processor board, microcontroller boards, right. And Adafruit, the people who created CircuitPython, have Python libraries that allow you to use different kinds of all kinds of different peripherals. I mean, an amazingly large number.
Mm-hmm.
If you go up onto circuitpython.org and download the system bundle, you can see the wide variety of things that you can attach to a lot of these microcontroller boards, and you'd be amazed at what it can do.
Right. Now I've been experimenting I've been experimenting with something called PyPy, Pypy. It's a Python version that has just-in-time compilation that
Yeah.
it achieves speeds very close to Python, if you know what Python is. Basically, you could take your Python and compile it, and it's kind of, you gotta go through hoops to do it. But the PyPy doesn't require you to do anything. It's just you install it and you run it, and it
Well,
works.
here it's a, and almost all of these boards, you could literally, what happens is when you attach one of these boards to your computer, right? It pops up a device called Circuit Pi. And on Circuit Pi, what you do is you drag and drop a file called code.py, which is your program, onto that file system.
Mm-hmm.
And then when you say save it to that file system, it automatically executes the code under the Circuit Python interpreter, which you preloaded, which comes preloaded on most of these boards.
Somebody wanted to know something about functions. I'm typing in a function definition now, which starts with the word def. I can go more over this when we talk in the next session, but in case you drop off. So you say the keyword is def, then the file name, a function name is foo in this case. I might put an argument here like name, which doesn't have any particular type. And again, like the while loops, you end it with a colon, and then you start on a new line. And so in this case, let's just print name, because we just want to make something quick and dirty. And then here I can say, that, and it should print Chuck. What did I do wrong? Mine's error.
I can't see your code right now.
Oh, I know what I did. You can't, too small?
No, it's me. It has nothing to do with you. It's not the way I'm viewing it. No.
Okay, there we go. Should see it bigger now. So I think the problem was, no, I told you that strings have to have the same ending quotes either side.
You forgot one.
Yeah, I had the wrong one. So now when we run this, it calls it the foo function gets called, and the name Chuck is the name, and then it prints it. And that is the bare bones version of a function. Did you have anything else, Linwood, that you wanted in particular about functions?
I think I did, because functions, the way I understand it, it goes in like lists depending on like which function is where. And so to my understanding, I guess what I'm having trouble with is understanding how things are called between different and multiple functions, if that makes sense.
Different and multiple functions. You mean like if I have two different foos or something?
Yeah.
Okay, I mean, you're talking about things like how do you do polymorphism and stuff?
Yeah.
You can't, not like this. Let's see if this works. Okay, so it shouldn't. It doesn't. And the reason it doesn't, the reason it doesn't, it's going to bake your noodle. But everything in Python is a dictionary. A class is a dictionary. Your namespace is a dictionary.
Well,
and in fact,
here,
go ahead.
Actually, I think polymorphism is actually refers to classes, not functions. Actually,
Function overloading.
Yeah, you can still overload. Yeah, you can overload functions.
You can achieve the same result. You just there's this thing called I did bring it up. I guess I can show you. You can ruin my whole talk for next time. That's okay. Just take your time. It's all right. Down here at the bottom, there's this thing called ARGs and KWARGs, that lets you pass any number of items and deal with it. So if you use the KWARG structure like this, you're basically going to pass it a dictionary of values, and it just can consume them because, notice I'm using this function up here to consume them, right? It knows that arg3 has a 3 in it, and it will match them up appropriately.
Yeah, but here's, you also have, you mentioned ARGs and KWARGs.
Right.
They're two different, there's an interesting difference between that, which you will probably get to, you'll probably be part of your explanation in the next part.
So ARGs is variable but positional, and KWARGs is variable and keyword valued. So right here, here's an ARGs version, which is basically a tuple. I'm just passing a tuple. No matter what I do, the value 2 is going to be assigned to the first arg because it's in the first position. The second arg is going to get 3, and the third is going to get 5. There's no way to outsmart the whole position thing when making a call to this function right here. However, down here, it doesn't matter because it's the names that make the difference.
That's a dictionary key.
Yes, and that's what a KWR is. It's basically you're passing in a dictionary. Now you can also do.
You actually don't have to pass a dictionary. You can say say you're passing something. Say positional a keyword argument called K. You can say K equals and then the value that you want to pass for K. That's what a keyword argument actually is.
So I think you can do this.
Yes, you can. You should be able to do so. That's right.
I say think because I'm typing on the fly and I'm afraid it'll.
Oh, you got it right. You got it. See, and the trick is when you call, when you make a function call, you have to put all the positional arguments first and then the keywords afterward. Otherwise, it gets fouled up. You'll get a really strange traceback.
Is that more depth? Is that better for you?
Yeah.
Okay.
Thank you.
And I guess my IDE of choice is Visual Code. And I'm not really a Microsoft fan, but it works really well. And you can debug and set breakpoints, and it's just so much easier to debug your Python with an interactive debugger.
I believe Daniel has a question. Sorry.
Daniel. Okay.
Yes. Hi. Can you hear me okay?
Yes.
Great. You mentioned earlier in the presentation there was like 100 and some odd thousand possible libraries, and it seems to me that there are a lot of libraries that are very, very similar. What's your algorithm for deciding which library out of maybe several dozen that can perform the functions you need?
Yeah.
How do you choose which of those several dozen?
I would pick the ones that have the largest number of polls, to be honest with you.
Okay.
Just because there have been occasions lately that some of the libraries have been malicious. There were a couple they found, and your likelihood of getting a malicious package when you've got 10, 20,000 polls is a lot less than 3 or 4 because somebody's been there before you. So it's a herd safety as a herd mentality, but it does work.
Sure.
Safety is in numbers.
Yeah.
In this case, the
Yeah.
more the merrier.
I want to get to Hunter's questions since Hunter is in the 9th grade now. So I started ago and never learned tuples, so that was something new. Oh, okay. Cool. I'm glad you found something new. I hope everybody got something new out of it.
Going back to the libraries question, are there
Sure.
reviews? Are there reviews of like, well, let's compare these 5 different computer vision libraries?
I am not sure. I would say that PyPy would be kind of the, wouldn't be. So you
for
got
that
training.
kind
Go ahead.
For that kind of system, what you might want to do is look for tutorials and see how each of the different libraries you're considering is actually used.
Uh-huh. Right.
Used in, hopefully they have have examples, and you can sort of see, you can sort of figure out which one is the easiest to use and does what you need to do.
Yeah. Also, along the lines of modules, I found it really useful to understand how to install modules without having to actually have access to PyPy. We live behind a corporate firewall, so you can actually download what's called a wheel file, WHL, and then install it locally with pip, which is Python install pack program, if you're not familiar. And also, when you make projects that you want to share, you can make a package of your own stuff, and you can actually package it, and they can install it right from GitHub. So distribution can become pretty easy.
Thank you.
That's what the you'll see sometimes. Oh, I think we lost the speaker.
No, I'm here.
Oh, you disappeared for a moment.
Oh, did I? Oh.
Yeah, that's what scared me.
Zoom. It's Zoom. It's not perfect, but it's way better than all
No,
the
it's
other
not
stuff.
you. I figured that much. That's why I waited to see if you came back. You'll sometimes see in installation instructions something that says run Python -m setup.py inside the directory where your source file is.
Right.
That's the alternative. That's the third alternative, actually. You get the source code, and it installs it into an appropriate directory underneath your Python
Right.
installation.
Right. So this is
Just like PyPy does.
Yeah. So this goes through how you create your structure. And it's funny because what happens is there's an init in your package when you do the install. You would create a directory structure like this. There's an init, and there's things that get done in there like, okay, take all the files that I have in my package and put them in the namespace. And so it actually builds a namespace up. It's not a lot of code, but it's interesting when you look at it how it all functions.
Yeah, it's the famous we call them the double underscore functions. We call them the dunder functions.
Right. So obviously, any function in that file would not get included in your namespace, but it executes by convention when you do an import. I'm trying to see an example of one. No, I don't see anything. Okay, but that's pretty much it. I'll take more questions. I got nowhere to go. Guess I got a little coffee left. They pay me in coffee. Okay. Well, if there are any more questions,
Yeah, so
I will. Go ahead.
Quick question. So one thing I find myself using tremendously in Java is hash tables. Do those exist in Python?
I think, isn't that a dictionary? I think you'd probably end up using a dictionary, right? You create your hash. Well, actually, you don't even need to create the hash, because the dictionary, when you put something in as a key, I don't know if I can scoot down here where we said, when we were using a tuple to index the dictionary, when it puts us in there, it creates a hash of that. Again, that's why it has to be immutable. So whenever I stuff something in a dictionary, it takes a hash of the index and uses that as the index into some structure.
And can I put an object as the value in that dictionary?
Yeah.
Okay. Yep. All right. Excellent. Thank you.
So essentially, I think what you were saying is does this does that work? Yeah, that works. Because, well, the tuple is an object. Is that how you do it? Nope, I don't know. I was going to show you the underside of the whole thing, that
Yeah, I didn't want to
everything
jump
is
ahead.
basically a dictionary.
I didn't want to jump ahead if you were covering it in the next section.
No, I'm not.
Objects.
I'm not.
Okay.
So anybody who got that now, that's good. I mean, this will build on. And it's funny, the next talk talks about object-orientedness, but only half of it is like you would traditionally use object-orientedness. There's a whole separate set of Pythonistic behaviors that you can leverage to do sort of the same thing.
Okay. Thank you.
And we'll talk about that in 8 minutes.
Anyway, I think what you might have wanted to do is print people dot dunder dict.
Dunder
The
dick?
underscore dict underscore, I think. I sort of remember that from
Like this?
yeah. No, you need the second underscore.
Oh, two of them.
Underscore underscore DICT underscore underscore.
Oh, okay.
Otherwise,
should.
no,
We can find out.
Oh. I just realized what it is, because I remember I asked somebody else
Okay,
about that.
third time's the charm. What is it?
It's the dir function.
Here?
People.dir will give you the underlying structure, I believe.
Oh,
No, parentheses. In
Okay.
parentheses. With a parenthesis.
we're not looking good here.
Oh, I know there's a way to do it. Hmm.
Yeah, see, self-dict.
Self refers to it. Yeah.
So if we
Chuck,
say,
can I, Chuck,
yeah,
can
go
I
ahead.
ask? Good. A question on the scope of variables in functions. If I have a function foo1, function foo2, two separate functions, can they both have and not interfere with each other a variable a?
Yeah,
Okay. And then
I
lastly,
think they could look at a global variable as well. So you could
That's
have
my next question.
out of that scope.
so they
So
can access global variables that are defined global, or just any variable that I'm using in the program can be accessed by the function.
If you
So-
use an A in function 1 and an A in function 2, they're separate.
Yes.
They're separate from
Good.
the
Perfect.
A
So the-
defined outside.
Right. But if there's a B defined
Just like in
outside,
C.
can function 1 and function 2 access B?
yes, I believe they can.
Yeah, just by
okay,
making things.
Can
This
they
is
mo-
my,
Now, this is bad programming. Can function 1 or function 2 modify B?
yeah. I think so.
Okay.
If it's defined as a global.
Yep. Yeah, it's bad programming.
So
Inside
why
the
did that,
function.
oh, wait, I printed stuff, where'd it go? Didn't I? Print. Oh, we're not calling anything. Silly us.
Print foo 1, print foo 2.
Okay, so now we 2 and 1. So it changed them. Now you can do that. And now you get the A from out above. And just to make sure that the second one didn't change A, we'll print A again. So this A is a different A than that A. But this A is the same as that A. Because you didn't declare anything. And believe it or not, I think you could do,
You can change that upper one here too.
hopefully this works.
Huh. Okay. Okay, thanks. I think that answers it. Thank you very much.
I think you can actually do this as well.
You shouldn't be able to change the, by defining it that way, you should not be able to change A from inside the, that def.
But you
Without-
can because
Oh, no.
this A is in the same scope as this function.
Oh, yeah, that's right. Oh, I see what you did. I missed what you did there.
And functions can have functions. They're private
Now,
functions.
you can't change that. Now, if you said print A here, and then you said print A after main. Now run it, you see, and.
Yeah. So anything set, because setting declares it, right?
Yeah,
If you don't do an assignment, it doesn't get declared.
yeah,
But
but
when you
here's the
assign it, it preserves the other value. Go ahead,
now,
what?
now, if you put right underneath this A, right above this A equals 1, put global space A in the main function, then that A outside will change.
Like that? Oh, like that?
Yeah,
Yeah, it did.
I think that's what I think is that's how you deal with global that's how
Because,
you tell
yeah, now you're saying,
Look at the
I want
global
to change
version,
one out of
not the
scope.
yeah, that manipulate. That's how I learned to manipulate a scope. I just learned this stuff about a week ago.
Yeah, I think, yep, Gloria said it. Okay, well, we got 1 minute.
Then we take a break and onward.
No, I think we're supposed to start in a minute. So I'll tell you what, give me 1 minute. I'll be right back.